Hey everybody, Mr. Artis here. I just wanted to take some time to go over one of the lessons that you guys are going to be attacking this week. The first lesson of this week is going to be focused on combined volume, which is kind of the next step to what we were doing last week. Last week's lesson we focused on finding the volume of rectangular prisms, and then also formulating or coming up with the formula for volume, which was length times width times height. So last week we were able to come up with the formula for volume, which equals length times width times height. The difference in today's lesson is we're actually going to be focusing on finding the volume of a solid figure that is made up of two or more rectangular prisms. All right, and the way that we're going to do that is we're going to do something called partitioning and decomposing. Partitioning means to just split up, and decomposing just means to break apart as well. All right, so when I look at this figure, I can see that this could be one rectangular prism and that this here could be another rectangular prism. So what I'm going to do is I'm going to partition or split this right down the center here. All right, now it's important to pay attention to the lengths of each of the given measurements. So here we have 5 centimeters, 8 centimeters, 2 centimeters. From here to here is 11 centimeters. The height here is going to be 5 centimeters, and then we have a measurement of 2 centimeters here. Now, the reason that this is so important is because once we split or partition this here, this is no longer going to be used as 11 centimeters. So I'm going to keep this in mind. I'm going to box this in for now, so I know that I have to come back to this. But in the end, I know that this 11 centimeters can be no more because I literally have just split it into separate parts. Okay? So now, after I've split these, I'm now going to rename these as Prism A and Prism B. All right? And for the sake of things, I'm actually going to write this out here. Prism A. I get my handwriting, I know it's terrible. And Prism B. All right? So now, I'm going to identify the denominations, the dimensions of each of these figures. All right, so I have my length here would be 5, my width here would be 2, and the height of Prism B would be 8. So the volume of this figure will be 5 centimeters times 2 centimeters times 8 centimeters. All right. Now, for here, it's going to be a little bit more difficult to figure out all 3 dimensions that I have for figure A. Reason being is because only 2 of the dimensions are given. So I'm going to have to kind of use some number sense in order to make sure that I can figure out what the length of this figure is going to be. So now that takes me back to what this original length of 11 centimeters was. So now I have to kind of combine the length of this prism, Prism B, to the length of this prism and Prism A, and when I add them together, I should get a value of 11 centimeters. So if the value or the length of Prism B was 5, and the total length from here to here was 11, then I must figure out, well, what plus 5 will get me to a total value of 11, and then that in turn will be the length of Prism A. So, because this is 5, and the total length from here to here has to equal 11, then that means the length here must be 6 centimeters. Okay, so now I have 3 dimensions for Prism A. So the volume for Prism A will be, and it doesn't really matter how you set the numbers up. I always kind of choose the easier way to multiply so that I can get some mental math problems, and it makes it a little easier to multiply. But the length is 6, the width is 2, and the height is 5. All right. So when I think about the volume of this, the way that I would multiply this to make this easier on myself, I would do 2 times 5, which is 10, and then 10 times 6, because this is now mental math. I can take the 6 and the 1, which equals 6, and then add an extra 0 for a total of 60 centimeters cubed, or 60 cubic centimeters. Same thing here, I would do 5 times 2 again, which is 10 times the 8 would equal 80 cubic centimeters. Okay, so now just for those who are visual and you like to see some more, this is prism A here. Can't really see what I'm shading. It's probably a waste of my time. This highlighter's terrible. And then I have prism B here, just so that you can see the difference between them. So that little green scribble is really blue, but it's turning green because the paper's yellow. This is prism B. This pinkish orangish color now, if you can see it, is prism A. So now in order to find the combined volume of each of them, I have to do my last operation, which would be to add 60 cubic centimeters plus 80 cubic centimeters. And there you would have your answer. So really I will be adding 60 plus 80, excuse me, 60 plus 80, and we would get our answer of what the combined volume would be, which would be a total of 140 centimeters cubed. So just to go back to see what we did, we started with the solid figure that was not partitioned. What we did was we split it down the middle here, or partitioned it and decomposed it. This is sort of like if I had the building blocks, I could put these together and make one figure and then break it apart to figure out the volume of prism B, also the volume of prism A, and then at the end combine those two volumes. So at the end we have what's known as a composite volume, which means we compose these two figures together, and in order to figure it out we had to decompose these figures. So I hope this helps. I hope this makes sense, and I hope you find this resource useful. Thanks a lot.